Hello. In this lecture, we'll see about temperature and humidity sensor and how to use a DHT11 module for your temperature and humidity sensing applications. Typically, if you see DHT11 can be identified, it will be blue in color, 22 will be white in color. When you compare DHT22 versus 11, both of them communicate over a one-wire protocol or the serial protocol. Over a single wire, you will be exchanging the data between controller and the module, and both of them operate at same current and same voltage. But if you see, number of samples from DHT22 will be much more, like 2 samples per second, whereas DHT11 will give you only 1 sample per second. And even the humidity range also, you will cover 0 to 100% relative humidity in case of DHT22, whereas 20 to 80% in DHT11. If you want to measure the temperature ranges minus 40 to 125, DHT22 is the better choice, and whereas DHT11 is limited to 0 to 50 degrees. And also the precision in case of 22 is 0.5 degrees, whereas 11 it is only 2 degrees centigrade. The basic construction is like the temperature sensor which is located on 11 or 22 is a negative temperature coefficient element where your resistance decreases with increase in temperature. And in case of humidity sensor, you can see it, the construction is like this. You will have a humidity sensitive polymer sandwiched between two electrodes, because of which when there is a change in humidity in the air, there will be a change in the voltage between the two plates, with which we can identify change in the humidity. You don't need to do all this. The IC associated with inside the DHT11 or 22 module will do this for you and give you out the data through a one wire. Now, how will we speak to DHT11? Basically, we'll send a request signal, and then there is a response from DHT11, and then there is data from DHT11 and an end of frame. How will a request signal look like? So from the controller, we should send a request signal which lasts for 18 milliseconds. Basically, as the DHT11 sensor, when you see as a module, it comes with a pull-up resistor, the 4.7K resistor. If you buy it as a module, it will look like this. If you buy it as a bare sensor, it will look like this. So the modules already will have 4.7K resistor mounted on pull-up resistor mounted on the module. So you don't need to worry anything. You can directly connect it. So by default it will be pulled up. So the one wire line will be by default VCC. In order to send a request, we have to pull it down for 18 milliseconds and pull it high again, which conveys to the DHT11 that there is a request signal sent. In response to it, DHT11 will send you a response signal, a low signal which lasts for 54 microseconds and a high signal which lasts for 80 microseconds. Then after, you will be receiving data. There will be 5 bytes of data, an integral part and a decimal part, and again integral part and decimal part. First two integral and decimal parts, first two 8 bits. This is 8 bits, this is 8 bits. These 16 bits correspond to humidity data, next 16 bits corresponds to temperature, and next 8 bits correspond to checksum. Total 5 bytes of data will be shared to the controller. And how will you identify a 0 and 1 inside the data of integral or decimal part? Basically, a 54 microseconds of a low state will be there even for 1 and 0. In case of 0, you will, after the 54 microseconds low state, you will observe a 24 microseconds of high state, whereas for bit 1, you will observe it for 70 microseconds. This is how we distinguish between 0 and 1. After the transaction is completed, after the sharing of these 40 bits or 5 bytes, the DHT11 will send you the end of frame or end of transmission, which is a 54 microseconds of low pulse and then a continuous high pulse, and the line will be pulled up. So even if you wait for more than 70 microseconds, you will not see a low pulse, so which conveys that there is an end of transmission. If you see the schematic, you require a pull-up resistor which actually comes with the DHT11 module. If you are working with a bare sensor, you have to connect the pull-up resistor by yourself. So in my case, I have connected the data signal or the one wire signal to D2 pin. This is the breadboard layout. This is typically a 4.7K resistor, and the application ideas include, like, you can for example, if you have a blood sample which goes through a channel, which goes through a logistic channel, now it's your responsibility to see what kind of temperature ranges it has been subjected to. If it has been subjected to certain range of temperatures, it will not be useful as a blood sample. And you can construct a weather stations, and you can do remote temperature and humidity monitoring, and you can even do plant environment monitoring for indoor farming also. Now let's go to the code. I shall try to import DHT. You don't need to really worry about issuing start signals, stop signals, request signals, etc. You can simply import the DHT module. Apart from that, also import machine module to work with pins. While true, we'll try to monitor the temperature and humidity continuously. I'll take an object D. Using the DHT module, I'll use this function called DHT11, which tries to take the machine.pin, which gives out the pin object to it. We'll just pass to it. It will create my DHT object. Now, simply by calling d.measure, we'll calibrate the required settings to communicate with the DHT11. Now, in order to measure temperature, you just have to call d.temperature, which will return you the temperature value, and d.humidity will return you humidity value. Now let us print it with the print statement. If you are using DHT22, better use DHT.DHT22. Even though it is same one-way protocol, the amount of data which will be shared will be in a different format. Okay, let us flash it. Now let me open PuTTY. I'll open my Node MCU. I'm seeing temperature very low because I have put my DHT sensor in my refrigerator and just now bought it. You can see the temperature slowly changing. Now I shall place it near to my laptop processor fan, which makes it more heated up. And now you can observe the humidity is also 50. As because the response time of DHT11 is only 1 second, you will not observe immediately the change in temperature. Now you can see the increase in temperature. It has changed to 21. It will take a little bit time. You will not observe it immediately, but you can see the increase in humidity. Even though if you print it fastly, you will not get updated values very fastly. Now you can observe the humidity has increased from 50 to 64 and temperature is at 23. Hope this explains how to work with temperature and humidity sensors and how to grab values from it. Thank you.